record on the computer. Try to keep it short so I don't fill my hard drive. And then what I'll do is I'll find that recording and then I'll upload it later so anybody that wants to watch it later can watch it. So hopefully people can hear me and they can see my screen. I think it should be working. I can see it all working. Okay, so we are going to talk about part 2 in Spark, the definitive guide. Sound good? So did you guys read it?
In the last 2 days, I crammed the whole thing.
You crammed the whole thing? Did you read it, Andre?
I got somewhere, I think I didn't read all the way where I was supposed to, but I got pretty far. My problem is I need to try it out, and I had some problems installing it.
Well, there's no reason to install it. So you don't need to install it to try it out. So were you here last time?
I listened to the
You listened
recording
later. Okay. So the first thing that you can do is you can go to databricks.com, right? And here, if you want to try Databricks, they have this community edition that you can get started with. And you just like fill out this form and sign up.
Okay.
And the cluster is available to you, you know, for fun forever, right? Basically, you might have to like save your workbook off or something and reload it. But for the most part, that cluster is free. It's like a 2-worker cluster or something like that. So that's one way to do it. Another way to do it is this way. So the Azure Portal. So Azure gives away, if you have an MSDN license in Azure, you get $150 a month for free. And that is, you can really use a lot of Databricks for $150 a month.
I have like free space in ML Studio.
Yeah.
It's apples and oranges, right?
Yeah, apples and oranges, yeah. But do you have an MSDN account? The other thing you can do is if you contact Microsoft, you can get an Azure free pass.
Okay.
Oh, is that me?
I'm just checking. Yeah, the Zoom's working.
Zoom's working. Okay, great. So if you wanted to use Azure, what I do is this. So I just type in Databricks, right? And the very first option is this Azure Databricks, right? And I click that. And then I click Create. And you have to name your workspace. So in Spark, there is a separation between the workspace and the cluster. Like the workspace is, if we're a team, we can all be working in a shared workspace, but we can have multiple clusters. Like we can have, most of the time we'll only have one cluster, but we can have multiple clusters that we're all sharing. And then when we go to run code, we can say attach to that cluster over there, right? But we can still all see each other's code even when it's not running. So the workspace that I'll do, I'll just call it SDTIG. And then I'll put it in the Databricks resource group. I think I've already got one. Yep. And then I'll put it in the West US because my ping time there is like 40 milliseconds. And then I'll make it a trial here, and then I'll click Create. And so this actually doesn't take that long to create. So it only takes like a minute. And then what will happen? Well, I'll just pretend like it happened, okay? No, I want to show it fresh. I'll show it fresh. There it is. So I don't think it's finished yet, but if you click on it, this is the Databricks service. And when you click this button, Launch Workspace, a new Databricks workspace comes up. Now, the coolest thing about this is that this sign into Databricks right now, this is Active Directory. And so I've used Databricks on AWS, and I've used Databricks on Azure, and AWS doesn't have this. So in Azure, if you have data in Azure Data Lake storage, and you spin up Databricks in Azure, you can use Azure Active Directory to secure the whole chain. So if you have like 100 data scientists and the data in Azure Data Lake Store is secured using Active Directory, like this user can only see this file, then when they bring up Databricks, their credentials carry through to the storage. And so they can only see the file that they have permission to, or the part of the file that they have permission to. So why that is interesting is because in a typical, whoever designed Spark didn't give a lot of thought to security. And so you can tell like a lot of their security is bolted on after the fact. And so once you mount something in Spark, like everyone can see it. So the security ends the minute it's mounted,
It's
right?
very much a back-end technology where user management is an afterthought.
Right. And so this kind of thing where we can use Azure Active Directory and carry our permissions all the way through, it's a really, in my opinion, it's a really cool benefit. And a competitive advantage to Azure, really. Okay, so it's taking a long time to sign in. I imagine it's just because this thing wasn't ready when I launched it. Yeah, but when I go to like launch the workspace, let's see if it works. Go. Okay. It usually doesn't take that long to like spin up. Usually it spins up pretty quickly. Uh-oh.
Murphy's Law is that it's not going to work for you quickly when you need it to. So
Right.
we
So
fully expect it.
So I can just pretend what it would happen in another workspace while this one spins up. But like if this is another workspace that I already have. And so in this workspace, if I didn't have a cluster, I would come over here on the left and I would click clusters. Now I do have a cluster here, this DBNYC cluster, but if I wanted to create a cluster, I could name it SDTIG, right? And then the most important thing that you can do in the cluster is clear enable auto scaling and put this down to 1, because what happens in a Spark cluster is it fans out across what are called worker nodes, right? And so there'll be a driver, and the driver is where you submit your application, and the driver controls the entire application. And then the driver requests resources from something called the master controller. Do you know all this?
No, I kind of know it just because we started using it at work. But please go ahead because I'm still new.
Okay, so the driver requests resources from the master controller. And the master controller can be kind of elastic. It can kind of say like, oh, you need 4 workers, right? And those workers all start in their own JVM. And so those workers actually can be on one machine, but they can also be on separate machines. And so the workers spawn up and they each get, according to the configuration of the Spark cluster, they get so much CPU and so much memory, right? Like you can say each worker gets a gig of RAM, right? Or something like that. So even though those worker nodes are how we're achieving parallelism, it's not fair to think that maybe they're on separate physical boxes. They might not be on separate physical boxes, but often they are. And so inside the worker, they will have a process called an executor. And the executor is reserved hardware resources that exist only for the application that the driver submitted. So the executors kind of spawn up and spawn down as they're needed. And so if an application says, okay, I need time, right? And the master controller says, okay, this is your degree of parallelism. And then they spawn up executors inside the workers, right? And then they start handing, data and work, in parallel, right? That's basically what's happening. So the point is, the reason why you're clearing enable autoscale while you're testing is because you don't want Azure to spin up 8 and then start billing you for 8, right? So it's not necessary if you're trying to learn PySpark and, you know, be good at Python or Scala, right? So do that and put it down to 1. And then from there, just click create cluster. And this cluster gets created, right? Yep, this is the meetup.
Okay, thank you. I gotta screw that up.
That's okay. Did you go to the wrong spot?
Well, you know what happened was, yeah, I kept thinking it was like, you know, when there's a 501 subscriber, I thought it was up that way. And
Oh, west, yeah. Right. So first is the 0. Yeah. Okay. So then once a cluster comes up, what you can do is when you go to your home screen, you could just say, I want a new notebook, and you can name it anything you want. Like we can say SDTIG, and then we can create, right? And you'll notice that this notebook is just like a Jupyter notebook, right? It's actually called a Zeppelin notebook, but it's fundamentally pretty similar to a Jupyter notebook, right? So over here on the upper left, I'm not attached to a cluster, but if I pull this down, you can see the SDTIG cluster or the DBNYC cluster are available to me, right? And if I pick one, I can start like, I can just start coding, right? And launching. Now in this case, this cluster has been idle for 120 minutes. So the cluster wasn't available to use. So in Spark, it's kind of cool because there's some elasticity in the cloud. If you use like HD Insight, or you use like Redshift, or you use you know, Azure SQL Data Warehouse or Aurora DB, right? When you say you want like 4 nodes, those nodes come up whether you use them or not, right? And so you could just start billing $2,500 a month, and they could just be sitting idle, right? But what Databricks does is, if you aren't using the cluster, it spins it down. And so the Azure billing stops effectively. You pay a blank space for the workspace, but the cluster billing stops. So you could keep a cluster online, you know, for learning, and really only spend, you know, $50 a month or something, maybe $20 a month, right? So if you've ever played around with HD Insight for Hadoop, or you've played around with Azure SQL Data Warehouse or like a Redshift, like that's ridiculous. Like you can't do anything in Redshift for $20, right? You turn Redshift on, you've spent $150, right? So there's no elasticity like this. So this kind of inconvenience that we have right here is actually a benefit.
Yeah, and that's some of that is the Databricks goodness, where they made it nice and configurable. Hey, after 10 minutes of inactivity, go ahead and spin me down.
Yeah.
And I think that's what Databricks says is a bit of a competitive advantage to using Spark naked just in virtual machines, or some of the other options.
Yeah. So when I was in New York yesterday, I was in Manhattan at the Microsoft, and a Databricks employee walked in and he said, I am the Databricks, I'm on the Databricks team for just Azure. And so Databricks, starting in January, has this whole consulting like arm only for Databricks customers in Azure. And they have another arm only, you know, in for Databricks customers on AWS, right? Mm-hmm. And then they have, of course, Databricks on Databricks, but Databricks on Databricks is actually Databricks on AWS. It's just they are white boxing it, right? So I guess it's not. Yep.
I noticed that you guys had YouTube your first session. Are you guys YouTube recording your all sessions?
Yeah. Yep. We're recording it now. Yep. What's that?
Just audio?
Yeah, audio is on my laptop. Yeah. There's a mic right there. Yeah.
I thought I saw the recording the video too for the first session.
Yeah, we're recording video too.
Oh, you are?
Yep. Yep.
Or just for yourself?
You've been captured for eternity now.
Yeah, just on my laptop. Yeah. Is that your plate? Did you need a plate? Did you get a plate?
Yeah, that's fine.
Okay, cool. All right, cool. Okay. So like, you know, if we want to like do a quick math, right? And run some code, you know, there's our answer, right? So this, in my opinion, is the easiest way to like get up and running with Spark and start playing around with it, which is why I kind of went through showing it, because it takes all of the setting up the JVM and installing Python and, you know, all the steps that they showed in the book. Like, you don't really need to do that. You can just immediately go to PySpark in this, right?
So Microsoft, they have an image or they stuff like that?
It's Databricks. It's a Databricks package on Azure.
So it's we can
Yeah.
think of it as a managed service.
Yeah. Yep. 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 Okay. So what, you know, how should we start? Like if we want to start at the beginning here, it's kind of a weird, the way they did the work here, they kind of started with data frames and then they worked backwards to RDDs. So I thought that was kind of unusual. Usually you start explaining what RDDs were and then tell people to ignore it and then they can go to data frames, but they didn't do that. So
Arguably good because a beginner is now just going to start with data frames.
right,
Yeah.
right. So what, do you guys know what an RDD is? Did you get to that part?
It's like similar to the database concept, right? It's a tables.
Mm-hmm.
Yeah. Yeah. Doesn't have to be tables, but yeah, it's rows and columns, that's true. It can be somewhat semi-structured, but yeah. Yeah, so the RDD idea is that, remember you know, I'm simplifying. You could think of these as other physical machines, but really what these are is they're just workers, right? Right, and inside those workers, right, there are executors, right? That's what these guys are, right? Okay. And then over here, the major component that we care about is the driver, right? There's other components here. There's a cluster manager and a master controller here, but I'm gonna take that off for the sake of simplicity, right? So when we want to, you know, take some data and put it into memory, right? What you end up doing is you end up loading that data from, let's say that you load it from a CSV, right? And what Spark does, and kind of like the black magic of Spark, is Spark looks at your data and decides, sometimes automatically, how many partitions that data is going to have. And then it divides up that data across workers. So what an RDD stands for is it is resilient. There we go. Resilient, distributed
Data something?
data set. Yeah, yeah, data set. And so this is the distributed part of it, where it's basically saying this part of your data is on this worker, this part of your data is on this worker, this part of your data is on this worker. Now, this is very similar to what Hadoop does. Hadoop does the same thing. The only difference between, well, not the only difference, but the main difference between Spark and Hadoop is that really this is all in memory, where Hadoop tends to be disk-based. It does the same thing, but it's persisting every step to disk. Spark operates exclusively in memory and doesn't do anything with the disk until you tell it to, right? So this resilient right here, that first word, this happens because inside each RDD, we have a concept of lineage. And what that means is when you create an RDD, let's say that you write code here. Is this helpful, by the way?
Mm-hmm.
It is? Okay. So let's say that you are writing code. You've got a lot of code that you want to write, right? And you say, okay, create an RDD from a CSV. right? And then you say like add a column, and then you say change a data type, and then you say, you know, do some math. Well, what you're doing is you're changing the RDD, and the RDD is recording what you're doing to recreate itself. So if a node goes down and another node comes up, Spark can recreate that RDD to the same state because, one, it knows where it got the data, and two, it was tracking how you changed it, right? So it's not super afraid of losing a node because it knows it can always get that data back to whatever state you need it in, right? In addition, Spark does lazy execution. And what that means is when you make changes here, these changes are called transformations. And then you're going to do something with those transformations. Like you're going to say, give me the max value, right? Or give me the min value, or count them, or just count distinct, right? You're going to do some kind of work, right? That work, when you do that work, that is called an action.
Excuse me, what was the feature or function called where you're saying it's not afraid of losing data?
That's its resilience, and it does it through what's called data lineage.
And it's a fundamental principle of Spark. I think most of the APIs that you use underneath the hood, it's applying this concept of being able to replay the same operations if it needs to because the node goes down.
Yeah.
So just out of curiosity, do you know if it's tracking that lineage at the RDD level or at the partition level?
At the RDD level, as far as what I've read. I'm not a Spark expert.
I think it may be
But-
at the partition level.
Oh, you think it
I
is?
think so.
Oh.
Because if once we read that CSVN,
Yeah.
to your point, it may end up what we think of as one single resilient distributed data set is in fact partitioned. The data is split across these different nodes. I think if one of those nodes goes down, it's going to bring a new node back up and get that partition populated again. So I'm not positive.
Because I'm thinking the
Yeah.
partitioning is not necessarily deterministic,
Well,
right?
I think it is.
yeah, I think when you specify a partition key, then the key is deterministic, right? Meaning the same record will go to the same partition each time. But you're right in that I've definitely created RDDs where I didn't specify a key and it partitioned
well,
it.
still could do a hidden
like-
deterministic way of doing it. But,
Yeah.
but my concern is if it's not completely deterministic, then
Right.
tracking once you start like sorting and shuffling, like to track all of that from the source CSV sounds like a pain in the neck. It sounds like it might be easier to just track it at the partition. But
At the
it's
RDD
not
level.
critical. I was just curious.
Yeah,
There's some
we'd have to look that up.
smart,
I'm not sure.
Clever people wrote
Yeah,
Spark, so
Brilliant.
right.
yeah.
Right. So this lazy evaluation says that when you do transformations, you're really not doing anything but parsing. And that it doesn't actually happen until you do an action. And when you do an action, Spark looks at all the transformations that you did up into that action, and then it parses the whole thing, and then it sees if it sees any obvious errors, like, oh, you can't do that thing you're trying to do because there's a data type problem. So it might kill it right away and say, you're trying to do a max on a string. Like, no, kill it, right? So it won't even bother executing it because it knows it doesn't have to do any work when you make a programming error, right? Oh, you're dividing by 0, kill it, there, done, right? And then if it goes through that kind of check, it creates a DAG. And the DAG, so it could take like 20 statements because they were all transformations. And then when it finally hit an action, it said, oh, wait, I actually have to do some real work here. And so I'm going to, oh, they're kind of doing the same thing here. I'm going to combine them, Oh, this thing, I want to single pass over the data. this thing I can parallelize, this thing I can't parallelize or needs a shuffle. And it creates an execution plan, a physical execution plan graphically. And you can see that, like, if we're over here and we look at, so this thing didn't have any real output, but I have a workbook that does have real output. It's just, let me come over here.
Can I give an example of that kind of optimization?
Yeah.
As you're chaining these transformations together, my understanding is one of the transformations can be a filter where we say, well, actually, I only really cared about a portion of the data that I read in from the CSV because I said
records that happen in California.
Yeah,
Right.
exactly.
Example is California.
Yeah.
Well, even though you didn't specify that filter right up front as you were writing out your series of transformations, when it goes to actually do the execution, it's going to realize, well, hang on a second, I can optimize this so that I'm not even reading in a bunch of records that later on be thrown out. And it seems kind of magical almost, right? But
it is magical.
It's cool.
There's a couple of things about Spark that are, even to me, black magic, right? And one is like, you can say, like what I'm doing right here, go get all this data, right? And then you can say, you know, a little bit later, you could say airports.filter, it could be like state equals CA, right? Now this won't work because I don't have state in there, but, and then you could say like airports.filter, origin equals Oregon, right? So you could put multiple filters there, right? And be changing the RDDs, basically you're building one RDD off of another one. And then at the final thing, you say, collect is a very common action that you do. Like, now show me what I did, right? And if it's an RDBMS, it's going to generate a where clause that only gets the subset of the records, that you specified, right? Since it's looking at how you're using it. That's what it cares the most about. How is this thing getting used? Oh, they just want a max value. Well, I can write that in SQL, and then they write a select max off the record set and give you the max. And they're like, we didn't bother doing all the things you told us to do. Like, we wrote it the way we thought it would be faster, right? So that's black magic to me, how that happens. And then the second thing that's black magic to me is it looks at like a partition data set in HDFS, and it says, I'm going to follow the rules of data locality, and I'm going to make sure that I only get the data that's closest to the worker. And if the worker's on the node, on the HDFS node, that has a partition data, I'm only going to put that data from that node into memory in that worker, right? So I'm not going to go over the network if I can avoid it, right? And so you're like, okay, how many partitions did you make? And they're like, 10. Okay, you do it tomorrow. How many partitions did you make? 7, right? Like, Spark is doing that for you, right? Now, it might do it wrong, and you might have to repartition or coalesce it, but there is some black magic there where it was making decisions about how to distribute the RDD according to how the data set was distributed or partitioned already.
And you can like explicitly override like the partition count. And in fact, I think in the book, I don't know if it's this book, but I think at some point he shows, hey, by default, it turned out to be 200 partitions that it was doing.
And we want
explicitly
5.
set it to 5.
Yeah, that was the coalesce that was in chapter 7, I think. He did that, yeah. Okay, so like here, I was going to show you this, airports.show, right? I could run this, right? This will run. And, oh, did it go dot? No, it was up. Okay, so it runs the command. This is running real, right? So it went to Azure Blob Storage, and it found this CSV in Azure Blob Storage. And then header equals true says, the first row is your header, right? And so it read that. Now, we could we can look at the results, obviously, right? But one thing that we can do is we can go into the Spark job and we can say, okay, you got something from the job for me, right? And when I view it, look what it shows, right? This is a very simple DAG. It's saying I collected some data for you, like you asked me to, right? And so if you come down to something that might be a little bit more complicated, like, let's see, like this is like, okay, from this data set, select everything and give me only 10 records, right? If we click on it and view it, oh, all right, well, I didn't like that. Let's
Rerun it.
let's
Yeah,
rerun
yeah,
it.
right.
It ran out because it's been a while. So now we view it and see a little more complicated DAG, right? Like this is how I chose to execute it. And these DAGs, like they're a great, you could see like, this is my stage. My stage was reacting to you telling me to do something like this from, right? And this is how much memory I was using when I ran each stage here. So if you have a really long script, right, you can break open the DAG and see exactly what portion of your script is the slowest portion. Which one might have like spawned a shuffle, something like that.
Do the stages, I don't recall, do the stages match up exactly with, we gave it 10 transforms. Are we going to see 10 stages?
No.
Or does stage have nothing to do with?
Nothing to do with it. So what a stage is it is a degree of parallelism. So, and I'm a little fuzzy on this part, but when it went through creating the DAG, it said, these things that we're doing here can be parallelized, but they're dependent on each other. And so these tasks have to run in order, but they can also run at the same time. Okay. And so the stage is almost like the degree of parallelism. Like this unit of work, I know I can parallelize.
So if we've got a couple of filters in there, those might all end up in the same
stage,
because
right?
If we determine that they don't need to be done serially, we can put them all together in the same stage.
Well, no, they can be done serially. Well, no, I should say they can be done sequentially, right? But not serially, right? Like a sort would require a serial operation, right? But without the sort, and actually that ends up not being super true. They can sort inside the partition if you're inside the key, and that won't be serial. But when they're sorting outside the partition, then they are shuffling. And that shuffle, like you said earlier, is like apparently the most painful thing you can do in Spark. Because
the shuffle, like we've got all this data distributed across nodes, and oh no, now we need to just like
switch
throw
it
all up in the air and
yeah,
catch it all again
yeah,
and see which nodes end up with which data, right?
Right. Yeah, exactly.
And that's part of where like it seems like my impression is that if you don't understand a bit what's going on under the covers, you do end up with, like you can have a program that seems to execute very performantly.
Under small data.
Yeah, but at some point, like you realize, oh my gosh, this step is just taking like 100 times as much. You realize, well, that has to do with the fact that it's doing a shuffle there. Well, why is it having to do a shuffle? And it seems like you do need to have some understanding to at least understand, well, why did that particular transform or operation actually cause the shuffle, right?
Right. Right.
Or to another level of detail, you can optimize your storage to reduce the cost of a full shuffle.
There you go. Yeah.
Right. Although that's the part I don't fully understand, because in Azure, the data can be partitioned, but it's never local, right? Like most of the time, the partition data is sitting in Azure Blob Storage or Azure Data Lake Store. So like for instance, this is a good example, right? I'm pulling this file out of blob storage, right? Now it's true that that data could be partitioned. Like in ADLS, it could be partitioned, but it's not local. The workers always have to go get it.
No,
so
I know nothing about Spark until I started reading the book. I'm just saying conceptually, if you're doing a join on two separate tables, right? And so you have like an orders table and a customers table. If they're both partitioned by customer ID, right, then even though you're conceptually doing this full join, you can get it where virtually all the same customer IDs are all
joining
the same worker node, so that 90% of what they're joining is just in memory, and then maybe 10% they need to shuffle because it's not actually perfectly lined up. Now, I mean, in theory, you can get it to perfectly line up, but even if it's not perfect, that's going to be a lot less expensive than if you had your orders partitioned by date and your customer table partitioned by customer. Then you pretty much guarantee that you're going to have to move 80% of the order data or the customer data, to a different partition in order to actually join.
Right.
Does that make
Right.
sense?
It does make
Yeah.
sense. There's
I
some
like it.
magic where, like, if you're doing that join, it hasn't actually like done the work even as you get past the bit of
When you
code.
state it, yes.
Yeah, exactly. So I'm
But
not
I'm saying you do the join, you do something, and then
Yeah.
you ultimately output it. Then it's going to have to do that. Now, of course, if it's not stored in your source storage,
Partition the same way.
partitioned by customer ID, the fact is you incur a lot of expense moving it around to get it, partitioned by customer ID. So if you only use it once, it's probably 6 of one, half does the other. But if you do multiple joins by customer ID, then paying that once up front, probably, I'm speaking purely theoretically.
No, I think it's right. I mean, it's definitely, I am new to Spark, but I'm not new to distributed data sets. And so that you're definitely thinking about that when you do Cosmos or Mongo or any of the other distributed data sets. So I know we kind of went off on a tangent there, but hopefully that was a little bit useful. So if we come back to the book, right? So chapter 4, they talked about structured API overview. And what's basically happening in the data frame is Python developers were really comfortable with the data frame already because they were using it in pandas. And so the data frame in Spark is very similar to the data frame that Python developers already were using. And so they use the data frame as a way of abstracting the complexities of the RDD. So, and you can even see that, like, if we go create an RDD, let's see if I've got one. Hang on. So if I come back here, I might have a good example of this. I've got a couple of Databricks workspaces kind of going at the same time. Because I've been showing it to people.
By the way, do you have the book notebooks loaded?
The what?
The notebooks from the book?
I don't have them loaded.
Okay.
Do you have them loaded on your laptop?
No, well, I didn't bring
I can do that, though.
but yeah, so I was saying, if you wanted to just go to like chapter 10.
That'd be good. Yeah. So like here, let's see if we have it here. So yeah, this whole text file, right? Like this is using the RDD directly. And so this is a very similar thing. Go to Azure Blob Storage and load this CSV into an RDD. And when we do that, and we print the type of it out, we get that the type is an RDD, right? And when we do like flights.collect, like, hey, show this to me, right? It shows it, this is what an RDD looks like under the hood. This is a RDD based on the file. This is, whole text files said, go get that. And so this looks pretty terrible, right? So you can see like even basic things right out of the gate with the RDD is a little difficult, right? But if we come back here where you already saw me work with airports, right? When I do airports.show, like that immediately it starts consuming in a way where it's comfortable, right? So you could kind of see that. And then when we do like print airport, that's a column. But if I just do print airports, right, you could see that this is now a data frame. So using the data frame as an abstraction is helpful right out of the gate, right? Even just like looking at the data, really helpful, right? And then you could kind of take a look at schema too. one thing that we can use for schema, and when you're in the notebook, by the way, if you see this plus sign, that means that I can insert a cell underneath it. So I can do like sc.sql describe full flights, right? So I'm launching a SQL command for describe, and then is it SQL? Yeah, it is. Why isn't that working?
SC?
That's my Spark context, but I can't remember if it was SC or Spark.
Spark.
Yeah, Spark. Okay. I switched halfway through. All right, there we go. So this describe showed me the schema immediately for this data set that I had, this data frame that I spun off to a view earlier. So the data frame is telling me, hey, look, you have 3 columns, and here's the data type for those columns. Now, if I come here and I want to save my airports to a table, right? So I can say like airports.save table, I think it is, or it might be save to table. Let me see. Save to table, and we'll name it airports. Okay, let's do that. What is it? No one knows? Hang on.
I'm trying to do a database
Spark
table. Spark database.
save a catalog table. Yeah. Data frame save table.
Sure.
Google doesn't help me with this really.
Go to Databricks.
Yeah, yeah, that might be the best thing.
That's
But,
where I saw it.
oh, you did? Okay. I'm just going to, real quick before I do that, see if I can, see if I wrote that code already someplace. And I think I did.
You're not trying to do the create or replace set view, are you?
No, I'm actually doing a real
You
table.
want to persist it.
Save as
Yeah.
table, but it's on data frame writer.
Save as table. There we go. So that where was I? Was I in SDTIG? No, was I in lab 3? So here, save as table. That is what I was looking for, right? Okay. So if I run this, do you think it's airports? That's not airports.writer. That doesn't look right. I thought it was just the data frame.save as table.
But they need an argument, or should the argument be something else?
No, that's the argument is the name. See, this is right. So let's see. With right.format source, no, that's.
Table.
Oh, look at that. So df.write.save as table. Okay, let's do that. So you were right. You were right. Okay, so now we have this thing saved, right? Now we could come in and take a look at the describe. And you can see, like, we have, let's see. This is not the right describe, huh?
No, I think he's still reading the data.
No, it should be reading the table, and that's not the right.
I think you have airports, data frame, and airports table.
You think what?
You also have airport data frame.
No, I don't think, so the describe I don't think will work with the data frame unless it's been spun out to disk. So.
Or that. What you said, the temp.
The temp.
Yeah.
Yeah, it can, just in case. I know, Grim, I know. Okay, let's see. No, this is the right one. And I know I've got a good version of this. Hang on. Do. It's kind of neat
Oh,
to.
try describe table.
Ooh, that sounds better.
Yeah.
I think you're right.
It sounds more table-y.
Yeah,
Well,
that sounds
I'm
better.
looking at the book. I'm not like,
Yeah.
I don't know this.
Yeah, I think you're right.
I'm just looking. Trying to follow along.
Yep, I like it.
It's actually impressive. You found
No, not
the right
describe
place in the
table.
book.
Spark SQL describe. Ooh, describe table. Yeah, it does say describe table, but that isn't. So I think we were doing it right the first time. So it's just describe in the table name, but that's not the right describe. I don't know why that's not right. What I wonder though, if I do spark.catalog.list tables, oh, you know what might be true is I might need to print it.
Oh.
That might be true. Nope.
What
Okay.
about if you, instead of print it like I don't know, do like a collect or something?
Oh, look at that. So you can see in the list tables, so this spark.catalog list tables, you can see airports, which is we created earlier. That's a managed table. Full airports is managed. There's full flights that I tried to use earlier. And then I feel like we're close. It's just, what happens if we do print? And I think it's schema. Oh no, isn't it print schema? I think there's something called print schema.
Oh, there's a show schema, I think. Maybe it's been split.
Airports.
But isn't the Spark way of doing it more like spark.sql.whatever than dot collect? So instead of print in front of it, put dot collect at the end, something like that.
You think that? Or dot show?
Yes. Isn't that
Ooh, dot show.
Isn't that more the way you do stuff?
Look at you. Nice. There we go. Okay, so this is an interesting thing. Like we see that just like we saw in the original data set, FAA, name, lat, lon for longitude, altitude, TZ, DST. Okay, yep. And then we see they're all strings, right? Even though clearly like those aren't strings, right? So they showed this in the book. One thing that we can do instead of header equals true is we can say infer schema equals true, right? So if we run it with infer schema, is that right? And it says, CSV got it.
Maybe.
It could be, and it absolutely is, yeah.
Sort of like shot in the dark.
Yep, it always is. Yep.
Camel case, right?
Yeah, camel case. Okay, so now we've got it. Now let's save it again. So we're replacing it. Oh, well, let's do full airports 2 then. Okay, now let's list the tables and see if it's there. And there's full airports 2, yep. And now let's look at the schema.
It's full.
It's the one below, right. Thank you. And now you can see the doubles and the ints, right? So infer schema gave us the correct schema right out of the gate. And now we can do like mins and maxes and all the stuff that we had in the book.
I think it's in RM, maybe. I'm sure I have to you can, when you're reading CSV, you can actually define column and data types. Is there something like that?
Yes, they showed that in the book. Yeah, where they were demonstrating schema on read and said, yeah, you can declare your data types. Yeah.
And in fact, I think they say, be careful. The infer schema is like spectacular for learning. Don't do it in production because it frequently causes 2 passes through the CSV. I think
No. It's because if your data changes and it's only reading the first 1,000 rows, you can cause your production job to fail.
that's even worse. That's even worse.
Yes. So it's the thing I hate where in Excel, you know, first few rows of patient ID all have numbers and no letters, but then the 51st row begins with an A before a series of digits.
Okay, so it's even worse than
the
that.
whole thing barfs because
Yeah.
Excel thinks it's an
Or
in
with
now.
Excel, NA or null,
Yeah.
depending how it's saved, it throws things off.
Yeah. Yeah.
Yep. So you can explicitly give it a schema or even tell it to load the schema from a certain file. And I don't remember what the format is for the schema, but
Yeah, I mean, you create a list and you just list out all the different column names and their types. I don't
Right.
know the exact syntax, but yeah.
Yeah, I thought that was a cool feature.
it's awesome. It's really cool. It's magical and concise,
Yeah.
which is the Spark way.
Yeah. Yeah. Concise, magical and concise, the Spark way. Yeah. Okay. So there was a lot of content here, and obviously we only have, you know, an hour or so. So I'm not sure that we can go through. In fact, when I was reading it, I kind of thought the reading assignment was too long and that we should have only done part 2 instead of part 2 and part 3. Because I said part 2 and 3 because I thought everything it did was like really similar to SQL, and it's not similar to SQL. Everything's really different. So it took me a lot longer to like work my way through the material than I thought it would.
So I don't know if this is a fair statement since I'm the guy who just tried to blitz through this in the last 2 days, right? But I thought my takeaway from part 2 is like, and again, I mean, I was coming more from I'm interested in learning about Spark as opposed to I have to write this pipeline starting tomorrow.
Yeah.
Right.
Yeah.
This is a different perspective, right? I'm not so much focused on getting the exact syntax right as just like how does this work, right? So part 2 for me was just like, holy cow, this is like amazing that you can pretty much do anything you want to do, and you can do it with SQL syntax or, you know, Python Scala type syntax interchangeably, even within one line, let alone multiple lines of code. Like I don't know. I mean, my big takeaway was like, you almost don't need to know anything about the structured APIs other than you can do whatever you want, however is convenient.
Well, until you actually try to do it.
Okay.
And then you're like, that was a lot harder than I thought it should be, you know, like, so I think, yeah, if you worked your way through a real world, like I want to take this CSV and I want to like add a column and I want to do a date diff and I want to actually do this window function. You know, I'm trying to become fluent in it so that I know it as well as I know other languages.
Toolkits are available for Spark.
Which sort of what?
Toolkits are available for Spark.
The toolkits that I know about seem to be around management, like the Spark History Server and the Spark Profiler and things like that. They don't tend to be around writing it.
And I'm like, there's not like a plugin for Eclipse or something.
No, not that I've seen, maybe, but there is a plugin for PyCharm, but I'm not sure that I've used it.
I used IntelliJ. I think I used IntelliJ for writing and debugging some Spark code.
You know, the resiliency sounds like a fascinating, because I don't really know too much about Spark, but it seems like it's similar to something like, they don't play with for a parallel sysplex on
Parallel what?
sysplex.
I'm kind of new to this world, but no.
Well, basically what it does is it allows you to runs on the IBM, their Z series mainframe services.
Okay.
And what they can do is they can run like 2 or more mainframes that are networked together. And so you can run transactions simultaneously on different machines, and they can roll back at any point in time, so that we never lose. It sounds like that Apache might be, resiliency might be capable of something similar to that.
They do have something that sounds similar to that called the Delta table, but I'm new to that and haven't used it yet. But I was just reading a little bit about it this morning. But to your point, Gordon, because I know SQL really well, and I'm like struggle in Python, I'm like, I don't know how to do this. I just end up reverting back to SQL. I'm like, well, I bet if I could just do it at a max in SQL, oh, it worked. Hey, that is the number I was looking for, right? Like, so to your point, that's true. It's almost bad where I'm like, I'm never going to learn the real way if I keep reverting back to my old habits,
But I would argue that Spark was intended that SQL isn't not the real way. It is just as viable
It's a weird,
as the Scala way.
you can express the same things.
And I think in the real world, like, I haven't experienced myself, but I work with a person who writes this, and there are some things where you do it better with Scala. Some work fine with SQL. Sometimes it's trial and error, which way you want to do it. And I'm still trying to get in depth here.
I would have liked to have seen a section that said, what are the things in like ANSI 2003 SQL you can't do? Because I'm just looking and it's like, oh, you got window functions and you've got group by and you've got
grouping sets
order by and group. It's like, okay, case statements work. Like, gee, I can do select, join, group. I mean, it even does cube and roll up. Like, what doesn't it do? Like that seems like, I'm having trouble thinking of something I want to do in a SQL statement, a select statement.
Yeah.
That it doesn't do. I mean, it doesn't do, update statements.
He scare you?
Yeah.
Sorry. Grim, go lay down. Come here. Grimmy, come here. Come on. Sit. Down. Down. Grim. Down. Okay. Here, how about this? I know.
Yeah, this is the SQL chapter.
Okay, go lay down.
You can imagine if you had 2 people on the team and one is really strong in SQL and one is really strong in Python. If you could imagine looking at their Git history and imagine like one guy like pushing it one way.
Oh yeah. That's kind of funny.
It's almost a question of style, right?
Yeah. Okay, so the other thing I liked is when he talked about the expressions, like, oh look, if you can't do it in Python, you probably can do it using this expression, method. And it's almost like you said, like this bastardized SQL hybrid Python, where you're like, just make this as this, and like, oh, it does it, all right, that worked. Doesn't feel like it should have worked, but that did work.
Well, so to your comment, because I'm also much stronger in SQL than Python.
Yeah.
It actually feels to me like the SQL, I don't know the history, but it feels like the SQL came first and the Python sort of came afterwards.
I don't think that's true. I think Java came first.
Well,
Java and Scala came first.
Scala came first, yeah. So I guess.
And I think Python came second.
But it seems to me that somebody architecturally decided we're going to support a SQL interface because, right, the way it just supports these SQL expressions and everything. I mean, once they committed to writing a pretty much full SQL parser, right?
They probably always envisioned from day one that there would be multiple modalities.
Because basically, right, like as SQL guys, you know that ultimately SQL needs to get parsed, and it's not a Spark DAG, but ultimately you have
You
this
get an execution plan
that's basically a DAG,
right.
You know, and then the optimizer does transformations on it, just like
Right.
Spark does
And
transformations.
it parallelizes and serializes and
Yeah.
blocks and
Yeah.
shuffles.
Yeah. Right. So in a sense, you know, they're but once they say like we're gonna have this really broad support and not just like a very narrow subset of SQL, like we'll just let you do a select with a where and nothing else, like big book, you know.
Yeah.
Then it seems to me like so when I looked at like the I don't know whatever like the window or some of these other things in Python and Scala, it just seems like such awkward syntax, like it's a lot simpler in SQL, and you just sort of
Well, simpler is just a matter of what you use to write. It depends who you talk to. Like I use SQL pretty much every day, but I see when people code in some language, for them it is easier to read, even something simpler or harder. Sometimes it's more like it translates what you get used to.
sure.
Yeah, that's why I'm trying to force myself to do Python first before I switch out, because the anonymous functions are still difficult to read sometimes. And so I'm like, okay, Lambda. So I'm handing this Lambda into a method call. Like that method call is going to do something with that Lambda. Like, what is it going to do, right? I have to I'm still like painstakingly reading it. Like, okay, it's going to do that. All right. Now, once it does that, you know, it's going to hand another Lambda to another, like it's chaining them, you know. And I've been trying to like guess what the DAG is going to look like before the DAG executes so that I get a little more fluent, you know. But the Lambdas are, you know, we have anonymous functions in C#. And so Scott had to be at a soccer meeting tonight, but Scott is really good with anonymous functions. So to him, he's like, it's the easiest thing, you know. But to me, I still have to like think about it a little bit. Okay. Was there anything like in the first couple chapters where we were talking about partitioning and coalescing, and this is where we also talked about different data types and dealing with nulls and date times? And then also about, what was the next chapter about? Aggregations, like min and max and distinct. Was there anything that anybody wanted to talk about there? I've been working with date time here, and like the amount of times you have to convert it to long to do any type of work with it and then get it out of long, like that part's not that fun. But I'm like, they need better date time handling here.
Times are painful in most languages, but yeah.
They're really good in SQL with date time 2 and offset and the localization. Like that's easy to understand. But here, try doing it like a time zone offset. It's not easy.
I didn't get that far. Is there a way where we can write down functions?
Yes. And it's actually really cool. So I can show you.
So I'm just thinking that would be an opportunity to practice to create our own functions for the date time handling.
So I don't think I have a good example of that right now.
No, I mean, I'm
oh, yes, I agree with you. Yes, I totally agree with you. I don't think I have a good example here right now of your own. Let's see. You know what? I think I might in my other Databricks. Did I launch this workspace? I think I did. So if I go back here. So here. Right. So this is not an anonymous function, right? This is just the defining of the function. And now this is the calling of the function, right? So I'm cubing here, right? And or I'm putting it to the power of 3, yeah. So yeah, so cubing, yeah, to 8, right? So this is half of what you do. The other half of what you do is you have to register this with the Spark context. And it might be the Spark session you register it with. But you basically have to register the function. And then once the function is registered, you can then call it in your data frame. You can say, take that column and convert it like this. Yeah. But I just read that today or yesterday. And so I haven't had a chance to write my date time conversion function to see if I can actually get that to work. But I imagine you can.
But the author does say you really need to write that function.
Oh, he said that.
Yeah, you don't want to write it in Python.
Well, okay, so I can show you that part of the book, I think.
Yes.
Because that part was interesting.
End of chapter 6.
It's this one, right? Yeah, it's this. Can I like right click and like, I want to.
Does he just make the argument that there's some transposition compiling into?
No, it's worse than that. Yeah,
Oh, it has to do with like the fact that it's having to cast a lot of stuff at runtime.
No, it's worse than that.
Okay, what's the answer?
So what it says is this, and Ted, tell me if I'm misquoting it. Okay, so when you have a Python UDF and you register it with the Spark session, I was right about the session, it fans out that function, right, Ted, to all the workers. Okay. Then when the workers get it, they can't interpret it. So they have to spin up a Python process that's in their memory space, but they don't know what's happening in there. And so if they throw that Python in the Python process and they tell it to do something, that Python process can start consuming so much memory that the worker process literally crashes. And the worker process will give you no warning because it didn't know that's what was happening, right? So all of a sudden you know you did something wrong because all your workers start crashing. So
it's like every possible way that it could be painful.
Yeah.
Spin up Python itself.
Yeah.
Right? It has to serialize your data to get it into Python.
Oh yeah, it has to serialize it to get it into
Python does
Python.
whatever it does, and Spark has no knowledge of how much memory it's consuming.
Right.
If it even works, it then has to serialize it back to.
Okay.
It's just like, why even offer this? This is like.
So that advice applies specifically, like if you're writing your general purpose Spark code in Python, there's little to no overhead. But if you're using these UDFs, that's where you get into trouble. Okay.
Now, a caveat, this book was written in 2017 or so this is revving hard. Like I can throw out some numbers. As of last year, there were 400 companies that had active Spark committers on their payroll. So just to put that in perspective, if you want to download the Spark source code, you can. And if you want to change the Spark source code, you can. If you want to commit back to the development branch of the Spark source code, there is no way in hell you will ever in your whole life get the opportunity to do that. They will not let you do that. So the Spark committers, it's like a frat. Like they all know each other. And so even though there are Spark committers at Yahoo and Spark committers at Netflix and Spark committers at Intel, even though they're in different companies, they know each other, right? And so if Ike comes along and says, I think I've made Spark better, they're like, it won't matter how good you think it is, it's not coming in because we don't know you,
it's
right?
a trust model.
Yeah, it's a trust model, right?
Yeah.
So, so to have 400 active committers means that those companies probably have a lot more developers on Spark, right? And that's not people writing Spark solutions. That's people extending Spark, like making Spark better, right? And so what somebody at Netflix would do is some schmo, let's say Ike works at Netflix, make Spark better. He would go to his committer, right? And say, look at my code, let me walk you through. And then my committer says, yes, I will make the commit request to get that committed, right? So when I say 400, that means there might be thousands or 1,000 developers on it spread across companies that will never get to commit without going through their committer, right? So, so these guys are full-time on the payroll, and many of them are full-time Spark committers. That's all they do is Spark. And including the developers at Databricks are Spark committers, right? So 400 companies. Yeah, Netflix, Intel, Facebook, Yahoo, all Microsoft, all with active Spark committers. So it does change fast. So anyway, this thing, which seems like an abomination, right? It might not be true anymore. I don't know. I'm sure they're not happy with it.
But one of the fun,
this is just for the Python, right? This Scala,
right?
If you write it in Scala, this is not
You're
good,
fine,
right?
right? Yes.
Right.
The Spark understands it. Everything is fine. Okay.
Right.
But I mean,
And just for UDFs.
Yes,
Right.
specifically.
Right.
yeah. I mean,
Right.
the thing is, it took me a little while to sort of figure out, like, basically, when I'm using PySpark, Python's just this like glorified user interface to submitting Spark.
Yeah,
I don't
to
know
creating
what
these
jobs,
tags, right?
Yeah,
I don't know, right?
they're batches.
Batches, but
Yeah,
but,
and they're going through, and their jobs, in the UI, their jobs. Like,
right. But I'm saying like when I think of what I'm normally using Python, I'm using Python to actually like crunch data, right? None of that's really happening with PySpark. You're just using Python as a
programmatic API.
a programmatic API,
Like an
in order to
SDK.
call the Spark API to say, here's the job that I want to do, and blah, 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 blah. What's different about UDFs is that it's a scalar function that runs on the worker. Everything else that I'm doing in this notebook is just talking to the controller,
The driver.
the driver.
Yeah, it's the
Right.
driver.
The
But
UDFs are happening on the worker.
I don't think that's true. I don't think that's true. So part of it is APIs of the implementation. So PySpark is using these REST APIs underneath, right? And it's giving you like syntactic help and IntelliSense and things like that to get you to these REST APIs. And it is hiding the complexity of the RDD, and that you'd have to do a lot of code by hand, where the data frame is doing that for you, right? So, so that's all very, helpful. But what you do when you create a Python job is you have the whole job, right? And then you are handing that entire job to the driver. So,
Right.
so it's not so much that you're, something's compiling underneath and then getting submitted. Like, it's the same process for Scala. Like, everything would be the same. It's just like, driver, here's what I want to do, and then the driver is going to treat that like SQL treats it, like compilation and execution, and then handing it back to you. So it's a little bit different than like a straight API, where a straight API is more of a black box, right? This is somewhere in the middle of a straight.
Okay. But like, maybe it's just my ignorance. Like, when I went to it, I wasn't really sure like how much Python was doing and how much Spark was doing. And my understanding and what you just said kind of sounds right? Like what I thought I learned is that Python's doing almost nothing other than preventing me from having to learn Scala. It's almost like it's syntactic sugar on top of, it's not, okay? But it's almost as if it were syntactic sugar on top of Scala. Right? Python's not really crunching numbers, and because of the way Python is, and it doesn't have types, it's not even doing any type checking, it's pretty much just, like you said, handing stuff off to the driver process. There's no, at no point is Python actually like adding two numbers as far as I can tell.
Well, that's not exactly true either.
Yeah.
Like in your Spark notebooks, right? Like if we open up one of our notebooks, right? We can import NumPy, and we can import pandas, and we can import, you know, the statistical packages, right?
Mm-hmm.
That we
Like
want.
or whatever,
Yeah, right,
Okay.
exactly.
Oh, so you're
And
saying so then, and then I can take those and I can mix them with my.
absolutely. Like if you say, go get that, right? And it's a low enough data set, you are effectively having the driver collect that data for you. So that might be a bad thing, right? We might have performance problems, but you could say, you know, okay, now give me the standard deviation of all of these things. Or if it's appropriate, I think it will push that to the worker. If it's operating on a partition, it will push the package, push the fact that you called an external package, send that to the worker, and do work there, right? So I think Python is doing some work, or it can do some work. And the only reason why I know that is because, one, I went through the book, had you import some functions, some packages with pip, and then play it in the. So you can get access to the CLI and in Spark, in Azure, and in the CLI, you can pip and bring stuff in, right? And then you can work with it. So, and there was also a little demo where we populated some data in pandas and then had Spark mess with it.
But I think, and just stop me if this is too much of a tangent, but I think it's still true that if I did all this work in pandas and then I wanted my Spark job to do something with it, it's still effectively giving that information to the driver. And then if it's part of the job, then it just gets compiled in as like, here's a number I'm going to use. And or if it's data, then it sort of has to then parallelize it out to the different, you know, workers or whatever. But like none of the, I don't know to say, it's like, yes, Python can do all the things Python has already done, but the Spark world is still, there's the driver that's between me and, because
the work
why I
being done.
brought this up is just because UDFs are different in that UDFs run on the worker processes. So when you made the comment, well, maybe by now with all the changes, like they fixed this problem, but this problem is different, and UDFs are fundamentally different from everything else in the first three parts of the book. And
Yeah.
everything else that we've read about is interactions with the driver, and this is the only thing I've seen so far that's actually happening on the worker.
Right.
node.
Right.
And so that's where this pain comes, because there ultimately is no Python on the worker node. So the only way you can do Python is it spins up a Python process,
Right.
serializes the data in, runs whatever your thing is, serializes the data out,
Right.
and then says, okay, now I ran some Python function at some horrible cost, but I did it.
Yeah, and I wonder if when they do like a sparkler for R, if it's the same thing. If, you know, the worker has to spin up an R process and serialize it in and out.
Yeah, I don't know if you can do UDFs in Sparkler, but I would imagine it's the same thing, that basically all you have on the workers is a JVM.
Right.
So if you want to do even the simplest of R functions, you're up the creek. You're going to have to spin up an R process.
Well, I'll tell you, I don't know the answer to this. So you may be right. Yeah. And if you're not doing it in the worker, does that mean that when we bring these packages in, we're making the driver collect all the data and we're making the driver do it?
That's kind of my point, is that your laptop may be doing Python stuff. And then whether it's a scalar single number or whether it's a small list or whatever, right? You're then going through the driver, and then if it's a bunch of data, ultimately telling the driver to go and spread it out
Right.
on the different worker threads. but that it seems like everything other than UDFs that we've read is just happening on the driver.
Right. Right.
But it took me a little
Yeah,
while.
I think that's
to sort of-
I think that's true.
It
I
took
think
me a little while to figure out, like, okay, I'm in this notebook and I'm writing Python, but what actually is happening?
Who's
here?
executing
And,
what?
and,
where?
and I was
Yeah,
doing,
yeah.
And I was doing the, the community edition, so I just have this pretty notebook on my browser, like, and I'm trying to figure out, like, physically, where is this
Yeah, where
notebook
is
in
this-
relation to the cluster and in
Yeah.
relation?
yeah.
And so eventually I was like, oh, okay, so really, like, the Python, whatever, executable
runtime
is
yeah.
running on a completely different machine than the cluster. It's running on a single box
No, it's
that's talking to the driver or something.
no, I think it's actually running in the driver.
Oh, maybe it's running on the driver.
Yeah, I think it's running on the driver. I don't think the notebook is. I think the notebook is submitting it to the driver, and the driver is running it and giving you the result back in the notebook.
Yeah. But in that sense, it's still separate from the cluster where all the other Spark magic is happening.
Right.
So I don't know if that was helpful or
No.
a bad tangent.
No,
It just took me a
I'm
while
still
to-
at the point where like it. So yeah,
Well,
any type of
when
repetition
you're
is
running
probably
things
really
on
helpful.
your computer, at least you can, at some level, if you know how, like, take a peek and see where all the processes are and which ones have to talk to which ones. But when I'm running on the cloud, I'm like, I don't know.
Yeah.
I don't know.
I think it is really helpful to think about what you're thinking about, because it is part of that process of figuring out, okay, this seems like way too magical. What's happening here, right? And I think it's really helpful to think about what you're thinking about.
Yeah.
And I think I need to do more of it to understand like what's going on underneath.
Yeah. Yeah. Me too.
I searched, there is some plugins for Eclipse.
Oh, cool. Nice.
Well, why wouldn't there be? There's plugins for Eclipse.
Somebody was
Yeah.
kind enough.
Yeah.
Yeah, but I wouldn't necessarily. I think one of the great things about Spark is the notebook interface, and so I would be inclined to continue to use the notebook interface and not to use a separate IDE, right? And there's a wide variety of reasons for that, right? Like when you go into the notebook, so this is the notebook, right? Like I can easily go into my workspace, right? And look here, and I can easily share it to somebody, right? So I can say like, hey, this other person can go into my workspace and look at the code I'm writing, right? Or you can go into this notebook and we can work on this together, right? So like I say, hey, Matt, Andrea, like Andres, we all are working together. And then we're all like making comments and making notes and optimizing. And then at the time that we're happy with it, then we just go up here, click schedule and just new schedule. And we say, run it every hour, right? Like, oh, we want to go collect this data and dump it to an Excel file, or dump it to an Azure SQL data warehouse or something. Boop, boop, boop. Okay, now it's running, right? That experience you wouldn't get if you were, that's one thing you wouldn't get. Right, and I think that's pretty impressive, that collaboration method of working together. The second thing that you wouldn't get is you have never seen me instantiate the Spark session or the Spark context, because Databricks is managing that for me, and it's doing it's saving me a lot of time when it sets up for me, right? So all of my modules are more terse. More terse or terser?
More terser.
More terser than they would be otherwise,
Yeah.
right? So I think all that to say, like, I think the notebook experience is a positive coding experience.
The one thing that comes to mind for IDEs is if you write your code in, I guess in my case, I wrote some code in Scala. I was able to debug, set breakpoints, and I don't know that you could do that.
So does that mean that in your IDE, you were able to attach
Yes.
the debugger to the cluster
Uh-huh.
and you were able to break?
Yes.
Badass.
Wow.
That's cool.
Yeah. I mean, this was months ago, and I hope I'm not misremembering it. But yeah, I'm pretty sure I was able to set breakpoints in as much as, there were variables in my application itself. I could set up watches for them and things like that. Yeah, I think it was remotely attaching to Spark, which is all kinds of impressive. Right?
Because I'm doing lame debugging through forensics, right? Like printing shit out and
Right.
looking at the logs to
Yeah.
do it right. It looks like it did it right, you know?
Yeah. And I think
So
I did,
that-
when I used an IDE, I did have what you're referring to. Like there were 5 lines of code at the beginning where it was like, okay, this is just setting up my Spark context, and there's some little gotcha that some people run into with that. And you have to do it the right way. But once I got past that, it was pretty smooth sailing.
I want to do that. I want to do that. I think that's cool.
I'm pretty sure I used IntelliJ. Yeah.
Visual Studio too.
You can?
Oh.
Visual Studio.
So look at, did you guys see Microsoft just announced this and they released it?
I Googled this just like a few weeks ago.
Yeah, Spark for .NET.
Well, and I
So
read about-
Microsoft, no, this isn't the right,
Yeah, there's a more recent.
yeah,
But
there's
I
a,
read about the conversation between the Microsoft developers and the Spark developers. And the Microsoft guys were like, okay, C# is, there's a world of us who do C#. We love C#. C# is great. Let's make it one of the new like core supported languages for Spark. And in the debate about it, the Spark guys were like, we will never do this in terms of we cannot
make it a first-class citizen.
make it a first-class citizen. It's always going to have to be a
Lagging.
separate, like add-on kind of thing. But I mean, I would be like, as awesome as Spark is, if I could do Spark and C#, I would be even happier.
Yeah, so when they say first-class citizen, what they say is, we will not release a Spark feature without making it available to Python and Scala and Java. Right. Those are the only 3 first-class citizens.
It's
right?
a breaking release if it doesn't
Yeah.
fully work for those.
If it doesn't fully work for those, we won't release it. And if we release it and there's a bug in a platform, we'll roll the feature back for everyone, right? We're not going to have this co-developed world where something's better than others depending on, right? So, and then, they're not going to make .NET a first-class citizen, but we'll make the URIs available to you. And if you want to, write the API over it, we'll support that, right?
Which to guys like us will end up meaning that it's very close to being a first-class citizen.
Yeah, I think so.
When it's all stabilized and whatnot, it's just going to work for us.
Yeah, I think so. Yeah, I do love that they did it.
It's awesome.
Yeah. Yeah, I think it is awesome.
C# is, and probably always will be, my preferred fall to language.
But at the risk of beating a dead horse, right? I mean, again, you're just using C# to submit jobs.
Mhm.
You're not really combining C#.
Right,
Spark.
right,
Yes.
right.
Which is, again,
Right.
to your point, Ike, right? You could do calculations in C# and come up with results and pass those results over, but you're still really just living in 2 separate worlds.
Yes.
Right.
Yeah, thanks for crashing my happy place.
No,
Yeah.
I'm just saying that.
I agree with you.
Yeah, it's just the IDE. But if Visual Studio can attach to the cluster and debug, and then you get all the Visual Studio debugging tools, that's awesome.
Yeah, that should come along with the C# support, probably.
Yeah. Makes me want to try it out. But I'm going to hold off
Do they have
because
debugging
I really want to be good in Python. So I'm trying to force myself to speak Python more than I am right now. All right, well, it's 8:30. I think we said we were going to go till 8:30. Did anybody else want to talk about windowing functions or about joins? The joins are actually cool, by the way. Like, we have more joins here than we have in SQL Server. And the syntax is really flexible. So you're like, oh, you want to do equijoins like this? You want to do natural joins? You want to, like, it's really easy to read and flexible. And it makes me want to go back to the SQL team and say, why can't you guys implement that? Like that.
Spark guys are making you look bad.
Yeah.
So one comment I had was, when we talk about working with complex types,
That was difficult for me to
I
understand.
thought that was like surprisingly easy to work with complex types. Like,
You did.
yeah, like oh, you want to do a group by, but instead of like returning a scalar like max, you can just like turn it into an array and return all of them. No problem. Like, oh, you don't like having that array, you want to convert it back into one row per element? Boom, explode it. Like, wow, I don't know what the performance is, but like syntactically, that was just really easy.
So that was interesting to me, yes. What was difficult was when they were talking about a data frame of data frames. I was like, oh, what is that?
Well, they're just saying that because structs don't have to be all the same type like an array, that you could essentially can think of a struct as a table or a data frame or as a whatever you want.
Oh, interesting.
It's like in our, I think there's like a list, right, where it could be like in kind of structure. Maybe I'm mistaken.
It's not list, but I do it in R. So in R you have data frames, and they're just like pandas data frames. They're just like SQL tables, right? Every column can have its own type. Natively, they never intrinsically built into R the ability to declare the type of one column as data frame. But there's also nothing stopping you from doing it, since everything's first-class object in R. You can stick anything in anything, basically, right?
Right.
And so there's this one pattern where you basically like take your data set, you split it up, and you store it in individual rows in a like master data frame, right? And then you iterate over that data frame. So for example, if I had data for 10 different regions, and I wanted to run models, but I wanted region-specific models for them, then I can run the same model algorithm on each of these 10 different data sets. But normally how I would do it is I would do something ugly where I have these different data sets, or I have some whatever, and then I'm writing a manual for loop, and
right.
Weird, right? But it's much cleaner if you just store them as basically just a single cell in a given.
You brought a lot up. So I haven't dove into the machine learning aspects of Spark, and from what I can read, that seems to be like 80% of the Spark community are just training models and producing some type of results. And so I feel like a lot of this was driven to make the machine learning aspect of it a lot easier. And so I think it'll become easier to understand, like when they were like hot vectors or one-shot vectors, I was like, why would you need that? And then I'm thinking about it, I'm like, oh, like I'm thinking about it still as a replacement to SSIS, where I'm like, that's ridiculous. But they're doing it because they're trying to do some type of Z-score, P-score, Fisher test or something. They're trying to get some analytics out of it. And then as soon as I started thinking about that, I'm like, okay, this is making more sense. And so I think a lot of what they do, they're making some type of mapping in their models much faster for them.
Well, they're keeping everything close to the data, right? So
Yeah.
all this Spark ML, well, I haven't read the chapter on Spark ML yet, but it's running on those workers really close to the data. That's the whole point of it, right?
Yeah.
And then sneak preview, somehow you can imagine like me being a SQL guy having this just static database. Now you switch to where it's streaming.
Mm-hmm.
And
it's
it all just sort of works with almost like no code change. Like I still don't get how that.
I'm really excited about that chapter. So well, I read a little bit about it already, and it basically said, well, if you look at a Spark job as just a batch, then a stream is just a micro batch. Like it's not really any different.
Yeah.
We're just running the same batch, but faster and more frequently.
Yeah.
I'm like, oh, that's interesting.
Yeah. So just sort of like, oh, okay, I incrementally added a few more rows to my data, rerun my model.
Yeah.
Yes, that's basically what they're saying.
Well,
right?
no, I think what they're saying is, look, we can keep track of the delta, and we can tell like Kafka or another pub sub, that there's data available to whatever your applications are. I think that's the theory. So by the way, it's 8:30, and I'm cognizant of our time.
Okay.
So I think we covered through chapter 9. So I propose that for our next meeting, we start at chapter 9, unless you want to keep going past it. But we haven't covered chapter 9 in our meeting. So my thought is that we go from, did you guys read all part 3? Did you guys read?
I still need to finish.
Skim quickly.
Matt, did you read part 3?
2 months ago, I think I read all of it, and it's just a coincidence that you guys are doing this, and I had done it, so I think I read all of part 3.
Oh, okay.
That's the RDD stuff.
Yeah, I think I did.
So my thought is, you've got the book in front of you. Can you go to part 3 real quick and tell me what page number that is?
209 is where chapter 12 begins.
How about
It's a short
How about chapter 9? Where does chapter 9 begin?
Chapter 9 is
160?
153 in the paper book.
Okay, 153. And you said chapter 12 was what?
209.
209. Okay, so that's RDDs, right? And then advanced RDDs.
Those are very short chapters. The whole section 3 is only like 30 pages. It ends on 249.
Let's
246. The whole
246.
section
And
3.
where did chapter 9 start?
153.
How about we try to read chapters 9 through 16? Where does 16 end?
So, let's go to table of contents.
Padre game.
So,
Oh.
so 280.
So that's good. That's 130 pages for next month. Does that sound good to you guys? 9 through 16?
So it's the end of part 2. It's part 3 on RDDs.
And the
then
beginning of part
first
4.
2 chapters. How Spark runs on a cluster and developing Spark applications.
Yep. Okay.
9 through 17.
I'm going to stop the share. Thanks, guys, if you're watching. Hope you enjoyed our silly meeting. Thanks.
Bye.
Bye.
I think maybe at least one person.
Who knows? But what I'll do is I'll